Chapter 6, Lesson 2, Proportions. So we're going to talk today about how you can use ratios to solve, to figure out some answers to some problems in terms of when you change the amount of something that's used, and you know how much used for one amount, how you can figure it out how much you're going to use for the second amount. Example of this is things like miles per gallon. If I know that that I have 10, or if I have 1 gallon of gas that I can go 30 miles, that would be a rate there. So 1 gallon, 30 miles. Then how much would I expect for 2 gallons? I expect 60 miles. That's essentially what we're doing, but we're setting this up in a way that it's as two ratios, and then it's pretty easy to solve based on that. And ratios are very similar in some ways, and proportions are very similar in some ways to working with fractions. That's why we work with fractions to start with. So, for example, if it just says solve the proportion 7 over 10 is equal to x over 50, what it's asking you to do is it's asking you to figure out what that x value is. And if you find the denominator that's the same, then the numerator is going to be the same. So what happens is that multiply the 7/10 by 5 on the bottom, multiply and you're going to end up with 50 on the bottom, and so you have to multiply the top number by 5 also, and then you're going to end up with 35 over 50. So then x is just going to be equal to 35 because the denominator is the same, so now you've got just what the value is. So if you were to use equivalent ratios for this, all you're doing is you're changing this number to that by multiplication, and then multiplying by the same number at the top here. So how do I change 8 into 24? I multiply everything by 3. So I have to multiply that at the top, remember, by 3 as well. So it's going to be times 3 and times 3. And that's going to end up being, x is going to be equal to 45, because I'm going to end up with 45 over 24 is equal to x over 24. And so x has to be 45 then if I multiply the 15 and the 8 by 3. Same thing here, I'm just going to multiply both by 4. And then I end up with x is going to be equal to 32. Because I multiply the bottom by 4, and I have to multiply the top by 4 if that's the case. And the reason why I chose to multiply it by 4 was because that's how I can change 11 to 44. Now in this problem here, it's a little bit different. Well, actually, this one's very similar. So let's look at this here. This is I'm changing just the order of the equation is different, but I'm still changing 17 into 34 by multiplying everything by 2 here. So I have to multiply this by 2 also, and then I'm going to end up with 34 x over 34 is equal to, multiply the top by 2 as well. So x is going to be equal to 6. For this one here, a little bit different. What's happening here is, again, same sort of idea here, except for now it's just going to be times 3. Because times 3 from 13 to 39, and times 3 from 12 to 36. So that's what my answer is going to be. So we also can solve proportions using algebra. This is frequently called using cross products, and so this I think will be actually easier to use in a lot of ways, unless it's really easy to see the relationship between the two numbers in the previous method. So, and this way will always work. So what you do here is, for cross products, you multiply across. So you multiply the x. Multiply the 15 times the 27. So let's look here. 15 times 27 is going to be 405. And then you divide by the remaining number. And that's going to give you, which is 45. And that's going to give you x's value. And the reason why this works, if you think about it logically, what I'm doing is, I have this set up. So what I'm doing here is that I'm going ahead and I'm getting rid of the 15. I'm isolating the variable by multiplying by the 15. So then it's just going to be x is equal to 27 over 45 times 15. And when I do that math, I'm going to end up with the same answer, which is just x is going to be equal to 9, because I'm going to end up with 405 over 45. I personally like to think of it as just this number, the two numbers times each other that are across, like in that way, divided by the one that's opposite the variable. So, for example, here, in this one right here, it would be 15 times 4, so that's 60, and then divided by 10. That's going to give me 6, and that's what x's value is. And for this one here, it's going to be multiply everything by 12, so 12 times 9, 12 times 9 is going to be 108. That's going to be divided by 18. That's going to be equal to 6. So for this problem here, it's going to be 16 or 15 times 16 or 16 times 15. I actually always like to start with the one on the bottom underneath the variable. 16 times 15 divided by 20. For this one here, it's going to be 12 times 35 divided by 15. So saying the proportions is a little bit more challenging, but here it says, for every $25 that you earn, you save $15. How much of the $70 that you earned earned at your after-school job this week will you save? Okay, so let's look at the problem here. So you earned $70, and for every 25 that you earn, you save 15. So you save 15 for every 25 you earn. And what you're trying to figure out is you're trying to figure out how much you're now going to save here if I make 70. So if you want, you could change this value, you could call it whatever you want. I'm going to go ahead and say this is going to be the amount that you saved us. Actually, I don't like that. It looks too much like a 5. Let's just call it M for money. So now it's just 15 times 70 divided by 25 is equal to my answer. That answer is going to be 42. So that's how much money you would save. So this one here, at a bookstore, 3 novels cost $17.97. How many novels can you buy for $29.95? Okay, so we've got our ratio here, 3 novels to $17.97. And now we have one thing that's really important. You need to keep the units so they're opposite each other. Now 29.95 is going to be there. And so it would be how many novels you can buy. And so it's just going to be 3 times 29.95 divided by 17.97. So your final answer is actually going to be 5. So, and again, in terms of recipes, this is important. For example, here it says Elise is making punch for a party that requires 2 parts fruit juice for every 5 parts ginger ale. To make the punch, she uses 18 ounces of fruit juice and 3 containers of ginger ale. How many ounces are in each container of ginger ale? Okay, so let's figure this out. Okay, so 2 parts fruit juice for every 5 parts ginger ale. So that has to be the proportion. If she uses 18 ounces of fruit juice, 18 ounces of fruit juice, then we need to figure out how many ounces of ginger ale she's going to use. So that's going to be, let's just call it G. Now, this is important. You're not answering the question all the way yet, because we still have this statement here about 3 containers of ginger ale that we need to address in a minute. But 18 times 5 divided by 2 is going to be equal to 45. So G is going to be equal to 45. Okay, now if that's the case, we need 45 ounces of ginger ale in order for it to be the right proportion. But if we have 3 containers, how many are in each container is what's being asked. And so that's going to be 45 divided by 3, which is going to be equal to 15 ounces. And we're done.